Right, so again, one reason that we didn't have a bunch of examples as we go along is because we really have to change very, very little, right? Most of the understanding of this unit is discovering why we're picking these activation functions and getting to understand why they work. Actually using them is trivial, right? So thanks to TensorFlow, you don't have to write any code at all. You just do this, right? So whereas before that would have said tanh, now it just says ReLU. And bam, ReLU units, right? So if you want to use the LeakyReLU, it's kind of a special case. Because it needs to take a parameter, it's an actual object that you have to construct. It's treated as a layer all on its own. It is the keras.layers.LeakyReLU, and it takes alpha as an optional parameter, and here I'm using alpha of 1, right? So instead of activation, LeakyReLU. TensorFlow has an implementation of swish. It does not include the beta parameter. I don't know why. I don't know why they didn't do a layer like this for it. I really don't. Because that beta parameter is supposed to be important, but they didn't include it. They just used a fixed value of 1. I'm shrugging, but you can't see it. I have no idea why. But we actually can add it very easily. This is the example of the functional notation. Remember that I told you that there were a bunch of different notations we could use. One of them was the functional notation, and then the example I used for the last lab was in functional notation. Here is an example of why we can, use functional notation to add a beta pretty easily, right? I can just declare it as a tf.variable, and then I can just write that, where that is swish, right? Swish was x times sigma, which is sigmoid of beta x. That was the forward pass. Using the functional style, we can just write that real easy. So now we have a tunable beta. Okay. So now let me summon up Spider. And let me open the right file. We'll do it live, kids. We'll do it live. Oh, yeah, I should probably also mention this. One second, sorry. Again, we'll do it live. Just cleaning up the demo. Cleaning up the demo. All right. Yep. I think that's everything. Sorry about that. So here, this is it. This is the demo we had before. This is just the MNIST demo I was using. Several people have asked me, is it going to work? Okay, it's going to work. It seems to be behaving weirdly differently based on this. I have not figured out what the deal is. Some people, it only works if you do 28-28. Sometimes it only works if you do 28-28-1. This is the one that I expect to work because this is the one that matches the reported dimensions of the MNIST dataset. I have no idea why just that is working for some people and that whole thing doesn't. I think it is somehow architecture OS related, but I don't know. Okay. But this is, with the confusion about what this term should be, this is the MNIST example from class. We see that it runs. it loads f.png like we were doing in the lab, it crops it, it gets the grayscale, and then it classifies it. This is the solution from the lab. We don't care at the moment, right? So if we want to switch from ReLU, or want to switch from tanh to ReLU, all we have to do is change this. That's it. Right? And it's running. So loss using tanh was 0.1825. Validation loss was 0.1825. Yep. And we got 1251. So our validation loss was lower with ReLU. That probably doesn't mean anything because that was one epoch and one test of one epoch, right? So where this lands is going to be highly random. We would want to run many longer tests if we actually wanted to feel like we were comparing anything meaningful. If we want to go to ELU or swish, we just use those by name. So if we mix ELU and swish, right, that was it, right? That's the entire code change, ELU and swish. And again, we are suddenly getting much better error backflow than we were before, right? So I did say that these have, basically for various reasons, these all have, in the positive half, their range is 0 to positive infinity, but in the negative half, they saturate to something. Fortunately, softmax flattens all of your values to the range 0 to 1, so we don't have to worry about that, right? Okay, mixing the two, we got a validation loss of 0.15. Again, that's probably meaningless because it's one epoch, one test of one epoch, right? If we want to use LeakyReLU, that's its own layer, so we have to write keras.layers.LeakyReLU, and it takes an alpha as an optional parameter. And again, they use 0.3. I'm sure they have some reason for that. They're Google. As far as I'm aware, like 0 to 1 to 0.2 are the recommended values. Oh. Then I failed to type. Shape? Oh. There we go. Functional API. Sorry. And again, right, that's it. Switching to LeakyReLU was just changing that from an activation layer to a LeakyReLU layer. That's it. So I said before that we can, using the functional API, we can easily introduce a beta controlling term. Okay, and that time we got 0.1288. Again, probably doesn't mean anything. We actually can do that, although we can move to a version of swish with beta very easily, right? So with the functional API, first off, we can just write this. So tf.nn.sigmoid is the logistical sigmoid. It is the function I wrote as sigma. We remember, right, that swish was x times sigmoid x. Using the functional API, we can just write that, right? X equals x times sigmoid x. And it's working. So that is swish written by hand. Notice that I didn't have to take the derivative of that. TF is still using autograd, right? So it is still taking the derivative of that thing automatically for me. This is a time where it might be a little less efficient because they actually do have a little bit of hand optimization in their implementation of swish. Although it's not bad, it certainly doesn't matter for this network, right? In order to have a beta, right? So in order to have a beta controlling factor, I need to have a beta. And what we need for beta is a tf.variable. And so this is what I'm doing right now is not intended to be a lesson on this. It is intended to be an introduction and motivation. We can talk about more things you can do with functional later. Right now, we can do a tf.variable. And let's say that I want to have a beta of 5. That's going to push it more towards being ReLU-like, right? Remember that 0.1 was very slowly changing, shallow, kind of line-like. 1 was sort of swish-like, if you will, dip and then positive. And then 10 was very ReLU-like, right? So a value of 5 is going to be, progressing toward being ReLU-like, right? And this is just, I need to add the beta in here. Right? So I've introduced a variable to hold my beta. I've added that variable as a term in my handwritten definition of swish. And there it goes. So that is intended to be intriguing to those of you who might want to experiment with that. It is also a thing that you can completely ignore if you don't want to, right? The takeaway of this chapter is you are often going to want to replace that tanh with either ReLU, ELU, or swish, or replace that activation layer with a leaky ReLU layer. That's basically the take home, is that all of these new fancy kind of hockey stick like activation functions are better than tanh for most problems. That is the take home of this unit, right? And if this seems neat to you, that TensorFlow is flexible enough that we can just do this, it is. All right, and did we get a value set loss using our beta? Be somewhere around here. 0.1295. Again, probably meaningless, but neat, right? I may as well go ahead and say there's also a tf.constant. Since this doesn't get changed, it didn't need to be a variable. There's also trainable equals true or false, right? Although, if we make this trainable equals true, it actually won't get trained because the Keras model doesn't know to do that. Trainable for a TensorFlow variable only matters with like the TensorFlow gradient tape. And again, that if you're feeling a little lost, then just flush that out of your brain. Doesn't matter, right? That's just sort of food for thought for later. If we want to look at what beta ended up being, we can do that. And we can see it didn't get changed. All right. That is pretty much that. I'm probably not going to bother posting this code sample for this lecture because there's not really a lot to talk about there, right? It just kind of, that's it. So, yeah, that is our unit on activation functions. And let me summon up my list and see what our next unit is going to be. All right. So next unit is batch norm and regularization. Should be good. Okay. Oh, and I should mention to you. All right, technically we're behind. Okay, I'm gonna go ahead and make a video break right here.